And now let's go ahead and get to the fun part. And by the way, I do want to say this, that I've had more fun playing with this FracRat and MFrac that I've had in a while, because I've always wanted to know more about fractal simulation, and this has allowed me to do that. So here's the logs, and this is the interval that we're interested in. It's your upper Wolfcamp. So we're looking at a real-life example here. What we're going to want to do first is we're going to want to go in and run the ZAC process. Here we have our caliper, our gamma ray. In this case, we're using a potassium gamma ray to more accurately represent clay content. We've got a Tixier permeability that we calculated in PowerLog, deep resistivity, neutron porosity, a bulk density, and a bulk density porosity. These are the curves that we need to run. So then we can go into ZAC and start generating average values over intervals for each of these curves. I'm going to zoom in a lot and take a look at the zone we're looking at. I highlighted the interval in blue. I just went in and created a quick zone called frac gross interval or something like that. And this is the interval we're going to be looking at. And I go into ZAC mode, and I can go in and I can add my zones. And real quickly I can go click, click, click. And I can get as detailed as I want, or I can go completely, that's on to say that one, and pick the zones as coarse as I want. And go through and pick the interval and scroll down and continue picking and do it. Now we've already gone through and done some of this. But first I'm going to show, so we have a lot of different capabilities. You can join zones where I'm going to eliminate a bed boundaries. You can delete zone boundaries, just go and say, I don't like you anymore, I'm defriending you. You can go in and you can edit your zone properties. If you want to say, man, I really think that should be cleaner than it is. What possible justification you have for doing that, I have no imagination, but then again, you might want to do it. Or you can clear those by going and say, no, I don't know what I was thinking, and go back to where you were before. Now what we're going to do is, since you can save these, we've already saved one, and we're just going to go in and recall one that we did before called webinar. And recall it, and then it's automatically applied. And I can zoom out again, and you get an idea of what we've done here. So we have picked a pretty substantial interval. If you wonder why this is bouncing around, I can stop at any point and read the values for all the curves. I can scroll over to see the other curve values. So we've generated this large table. Once we've done that, we want to go ahead and write that to the database, and we have this function here that says create the curve data. Because we're going to put the curve data into our database, and we're going to give it a prefix, because we do not want to overwrite our original curve data. That's just a bad thing to do. We're going to make ZAC curves as opposed to block curves. You know, we have a geophysical side to this CGG geosoftware company, and they like block curves. But the engineers like ZAC curves. And we can do it in a bottom-up or a top-down format. And if you don't understand that, you can contact us, and we'll go into detail, because that's just a little bit confusing. You run it, and it just generates all your curves. And at that point, and I'm not going to resave this table, at that point you're now ready to go into FracRat. And that's this guy. So here's FracRat. And FracRat consists of one module with a series of tabs, and you go through them from left to right. If you don't have a TVD curve, you can use the depth, and assuming it's a straight hole. So in here we're doing our bottoms-up average value curves for the neutron, resistivity, gamma ray, density, caliper. We have a whole bunch of different options. If you're using caliper, you may want to apply a hole correction to correct for your mud weight and washout. You may want to input your gamma ray index externally, at which point your hole correction won't apply. And then, or you can use this gamma ray clean and gamma ray shale and calculate a gamma ray index in here. If you put these to 0, and this is true throughout the FracRat module, it will go in and determine the value for you. In this case, it'll take the minimum and maximum of the gamma ray and go ahead and compute a gamma ray index, and then it will convert it to a V shale using either tertiary algorithm, a Mesozoic, or one that uses a bulk density and a gamma ray. These are kind of old rocks, so we're going to use tertiary. The tectonic constant accounts for tectonic stress. I'm just going to set it to 0.085. And then the pore pressure I left at 0, so I'm just going to grab the mud weight. So you start to get a feel for how this works. I'm just going to change a few of these values, and you'll see why in a second. So I'm putting in the density porosity of shale, the neutron porosity of shale. We'll just make it 22 for the sake of argument. This calibration factor, now this was important because if your reservoir is depleted, then you put in this calibration factor to account for that depletion. And then the depletion will be distributed as a function of V shale and permeability. Because a zone that's 80% shale isn't going to deplete, and a zone that has no perm will not deplete either. So let's go look at rock properties real quickly. We have a variety of methods to Wapuan, Castagna, neutron. If you've actually measured your shear and compressional sonic, you can use deterministic methods. We're going to go with neutron. I've checked this against multiple wells in the area, and neutron does a really good job. These are calibration factors where if you've done triaxial core measurements, you actually know what the values are. You can then use these to make sure these match calibration, match the core data. And then here we're converting from dynamic to static. We have a variety of algorithms available, and I kind of like that one. The other thing of interest is your fracture toughness, which is a local factor. Your local engineers will know that one. Go to fluid loss. Here you mainly need to know things like viscosity and compressibility. And you'll note that the rock properties generates all the curves you need to input into MFRAC for rock properties, and your fluid properties is the same, whether it be your reservoir pressure or your viscosity or your reservoir stuff. So let's go ahead and run this. Boom, we run it, it's done. And now we're going to tune it a little bit, and here's what I was going to show. Here we said the density porosity of shale is about 15. We can actually go in and cross plot once we've determined the V shale and say, no, it's more like 12. And say, okay, cool. And you'll notice it fills it in for you. Same with the neutron. You notice it's 28.433, boom, and the neutron's already filled out. And then you just run it again. And at this point, I'm done. I say, okay, engineer, ready for you. Go do your stuff.
All right. Thank you, Fred. You can take a break, but don't go too far.
No, just down the hall.
Okay. So what we'll do real quick is we're not going to spend too much time on MFRAC because we would like to focus today on the workflow and the connection between power log frac and MFRAC. And also a lot of our users, I'm sure, are pretty familiar with MFRAC and very intimate with the software. So I won't spend too much time on it. But let's go ahead and just point out a few things with the software. So I'm going to bring up our data options and a loading screen real quick. So before we go in, I'm not going to be able to go through all the different options for the frac modeling within MFRAC. But essentially, think of this first few screens in this data options menu as your recipe for your frac design. So whatever options that you select in this first three tabs, so your general, your fracture, and your proppant tab, essentially you're trying to design what type of frac job you're going to do. So that's going to determine the data input that's going to be used in this next few screens down the line of this workflow. So for example, if you're trying to model a foam frac, if you check on the foam box, that'll alter how your treatment schedule is going to look like to include some of your foam properties, right? You could also select if you're in design mode, or you could combine that with our data acquisition and display module, MView, and run it in a replay or real-time mode. So if you're out there in the field, you can do some live or real-time changes to your frac model. And so there's other properties, the fracture proppant tab, the fracture tab, the proppant tab. So you can take into account things like various proppant settling modes, the proppant transport methodology. If you're out there doing a proppant ramp, you can take that into account as well. So these first few screens are going to be your recipe for your MFRAC design. And so again, I'm not going to get into any of these options, but the help guide, which you'll find at the bottom right of the screen, is actually going to be one of the best help guides for any software that's out there. Mr. Myers and all the other guys that have worked with this software have put together a very, very comprehensive and a very useful help guide that points out all the different data options that you can use. And Fred also would attest to how useful the help guide has been to his fracturing knowledge. And so moving on down the line, so in line with what Fred pointed out earlier in PowerLog frac, what you can see is in MFrac, we're also working from left to right across the different modules. So that way, we're sort of maintaining a workflow, and so it makes the connection and the learning curve not as high between PowerLog frac and MFrac. So here you put in your wellbore hydraulics data, right? If you're going down casing, going down coiled tubing, or tubing, you can take that into account. And so, just to point out what I mentioned earlier about limiting the amount of data that you need for your model if it's not required in MFrac. So say I select a coiled tubing option, and I go through that. What you see now is a coiled tubing tab comes open, and you can put in your information about your coiled tubing. But if you don't specify that, that tab goes away. And so that way, the software is kept clean and free of clutter, so you don't get confused with the data that you have to bring in. And so you just work through the tabs left to right, put in your wellbore deviation, and there's different survey methods that you can use. We're just modeling a vertical well in this case. And so you put in your casing information, your tubing information, and at the end you can view your wellbore profile. So that way, just work your way from left to right across the software and you'll avoid any issues. So if you're missing any data or anything, you get a pop-up screen that'll let you know that you missed something and you need to go back and put it in. And so moving on to the next screen, this is where you put in our preparations. Now, this is where PowerLog frac is also going to be useful. So I'm going to call back our trustee petrophysicist, Mr. Fred, to come over and help us try to decide what zones we're going to perf and see if we can pick that out in PowerLog frac.
Okay, Elijah, you want to know where to perf? Yeah, come on, I thought you engineers just perfed and fracked everything. That's been my experience in the past, but clearly I was deluded. So let's go ahead and bring up our log plot again. Now we know we're going to be somewhere in here, because that's the area that we're looking at. But let's bring up PowerLog. And let's go ahead and get out of FracRat for now. Now let's do some interpretation, and let's run Quick Look. Quick Look is a module in PowerLog that allows you to determine the porosity, water saturation, V-clay, and generate the effective porosity, water saturation, buckline water that you need to go in and evaluate your reservoir. So we're going to go ahead, and we've already filled these out. It's really simple. Indonesian, you just give it a few important characteristics that you pretty well know these numbers, and we just run it, boom, and I'm going to calculate all the numbers I need. So now I want to display this in log plot. I've actually saved this track because I use it in so many different modules. And I'm going to grab my Quick Look track and I'm going to put it right there. And so now I can see that in the upper Wolfcamp, I've got a zone that looks pretty darn interesting. So let's go ahead and zoom in on it. And we'll go in here and go, yeah, that zone looks to be the best zone to interpret. Now, if I wanted to go in and say, you know, I think I'm being a little bit pessimistic on my water saturations, I can rerun that. Now I think I'm being optimistic. I think I'm going to go with 108. So I can adjust all the parameters here and easily get the values that look most reasonable and representative. So now that I'm looking at this, I think we probably want to perf this low here and let it frac up. So maybe from 9705 to about, that's about 9757. That'll get us the majority of that. And I've highlighted that in gray. This is the zone we're going to be most interested in. So there's your perfs. Okay, Elijah?
Okay, thank you, Fred. So I'm going to go ahead and trust Fred and use those numbers in this frac design. So I'm just going to call it, give it a name, just call it perf zone test. And so let's go ahead and put those perfs in from 9705, you said, to 9757. And so again, you can put in up to 10 different perf clusters within MFRAC, but for this case, we're just going to take into account the one. And so in the zones data tab, there's other options that you can specify. You put in your number and diameter of perfs. And if you want to take into account perforation, erosion, you can do that as well. But for this case, we're just building a quick, simple model that's just going to demonstrate the workflow and the communication between Paralog frac and MFRAC. Put in your pay zone information, your permeability. This is going to affect your dimensionless fracture conductivity calculations. So these values are also important to take into account as well. And so again, once you put in your perforation information, we'll maintain our workflow and go to the next page over. And so this is where you have your treatment schedule. Again, we just picked out a basic treatment schedule that we're using. This is just a 60 barrel a minute cross-link job. The thing's about a 15-pound cross-link job. And so, but in this treatment schedule, you can go in and you can specify any type of design that you want. So this is where you have a little bit of room to play with your hydraulic fracturing design. So in here, you have a fully customizable fluid database and proppant database. So if you're with a particular company that has a fluid that's not within the database, you can go in and change, input your own fluids and input your own proppant as well, and use that in your fracture modeling design. Now moving on, let's go ahead and go to our rock properties menu. Now this is where the power of Paralog frac and MFRAC workflow comes in. Now ordinarily, oftentimes what we find is this is a difficult window to generate, is your rock properties, right? So sometimes there's going to be a communication gap between the geomechanics department or the petrophysics department to generate this. But with Paralog frac, completions engineers can easily generate their own rock properties and do their designs along with the hydraulic fracturing modeling. So we'll keep Fred on the sidelines for a second, and I'm just going to go back into FracRat and go into our rock properties table. So now, Fred has been kind enough to do all the analysis and everything on the rock properties. And now again, you can go back and customize this to your own particular design. But let's go ahead and import this calculated rock properties into MFRAC. So I'm going to click on this export button. And so what you notice here is that the columns specified in FracRat are lined up exactly as they are within MFRAC. So what we have now is just an easy copy and paste functionality, or you can export and import a text file, right? But here, since everything is already lined out and we already have a column that's created for MFRAC, all we have to do is just apply this mapping, and you have your rock properties calculated and lined out exactly as they are to be imported into MFRAC. So if I click this copy selection in the clipboard, I can easily go into MFRAC and paste that directly. So now, with just a few steps, we've easily computed our rock properties that we're going to use in our design. And we can do the same thing for our fluid loss properties. So now I'm going to go back into our trusty FracRat and go into our fluid loss properties and repeat the same process, right? So export, we're going to apply mapping. Everything is laid out exactly how it would be in MFRAC. So I'm going to copy that and paste it in our fluid loss column, right? So now we're able to generate our fluid loss and our rock properties pretty easily. Now this is one of the most important parts of your hydraulic fracture design, because your stresses, your Young's modulus are going to control your fracture propagation, your width opening, and various other things like that. So your rock properties and your leak off are important parameters in your hydraulic fracturing design. So what FracRat and Paralog frac allows you to do is to confidently generate those values and those properties. And this is going to be a huge step in accurately designing our fractures. And so after those two screens, there's just a few more screens to go in. And you can take into account proppant, some embedment, just put in your closure pressure on your proppant. And so again, these values, these values are going to be pertinent to the area that you're dealing with. But for this case, we're just demonstrating the workflow using connection between Paralog frac and MFRAC. So once those values are done, now you've built your frac model pretty quickly. right? So without sacrificing too much in time, you're able to generate your raw properties, generate your fully lost properties, and now you have your frac model in there. So within mFrac, we're just going to go ahead and quickly run this simple simulation and take a look at some of the things that we see. Now, Fred doesn't like this very much because all we have here is just, numbers, and Fred likes to see a lot of pictures. So what you can do is there's different plot categories that are within mFrac. So again, you can go through each one and select the different plots that you'd like to see. But one of the things you're also allowed to do is to generate a template. So every time you open up the software, you don't have to go in and create those plots again, but you can just load them up pretty easily using the template. So we already have one that we created that we're going to look at. So we're going to bring this up and take a look at some plots. So on here we have our treatment design plot with surface pressure, bottom hole pressure, our concentrations and rate. We also have a 3D plot, right, and our stress width profile and width contours as well, fracture conductivity. So there's various plots that you can look at to estimate your fracture design and how good your design job was. And keep in mind, all this is available in real time. So while you're bringing in data, pressure, time, concentration, and rate data, you can do all this in real time as well. And so Paralog Frac becomes, you can see how Paralog Frac fits right into our mFrac workflow, right? Because the generation of this rock properties and fluid loss properties become an important tool and a very, very useful tool in doing your hydraulic fracturing design. Again, so now you can start to view different things with your fracture height, your width variation, also your length, take into account your fracture conductivity. And so you can also generate a report. So aside from looking at the plots, you can go in and there's various report formats that you can bring in, a full report, a summary report. And you can go in there and take a look at your different fracture properties for the job that you created. And now, so just with that, this concludes the mFrac portion of this design, but there's one more thing we'd like to show you guys, because obviously it's not just about the initial design. Whenever you go back in and you run a MinFrac, for example, you can go in and make some changes to your properties. And also that's taken into account into FracRad. And I'll let Fred come over and demonstrate that with the parameter tuning.
So when they go out to the well site, sometimes it helps you actually know what the values are that you're dealing with. So in this case, we're going to go back in and we're going to go back into FracRad. And we're also going to bring up a little listing of some values. And then we're going to have to talk to our engineers again. I know, that's sometimes difficult, but it's required. So you went in and did a mini frac over a limited depth interval, and what was the stress you measured across that value? So in this case, it's about 76550 is what he told me. So that's pretty good. Let's go take a look at what we actually computed here for stress. And it looks like we weren't too far off with our stress values, right? I mean, let's run this and make sure everything's updated, and yeah, nothing changed, so everything's fine. So we'll do that. We're going to vary our tectonic constant from 0.01 to 0.04 and see what our stress values are going to be. And we're going to change the number of iterations. 100 iterations is a lot. You can usually get a very accurate estimation of your input parameters with about 20. And then we got to make sure the interval represents where they actually did the mini frac. So you can't run a whole interval. So you did a mini frac from about 9709 to 9757. So much smaller interval than the tire gross interval. And then you run search, and then we'll go through, and it will find the parameter, the values of this parameter to generate that exact value. And so in this case, it changes your gradient to 0.10807 for your tectonic constant. And you want to apply results, and you say, yeah, I do. I do want to apply those results. And then I want to go ahead, and what that means is it changed it in there. What that means is that now you want to go through and you want to rerun this module over the entire interval. So we rerun it, and then we regenerated the rock and fluid properties over the entire interval. And although we're running short of time here, because we want to give a little time for questions if there are any. So well, we can take these values in and put them back into MFRAC and regenerate the FRAC model, and with parameters that have been tuned based on data that you've got from the wellbore. And that pretty much concludes what we're going to show here today in terms of how you can use PowerLog FRAC and MFRAC together to generate a nice, efficient, and effective workflow. And I'd like to say we here at CGG GeoSoftware would like to thank the Baker Hughes Pressure Pumping Group and for their cooperation in developing this product and helping us put together this presentation. So now we're going to open the forum for any questions, and if you'll press the hand raise button on the control panel, I'm getting these hints from my marketing guy sitting next to me, Powell Simulan. We'll go ahead and address any questions that the audience might have. No questions? Hold it, we nope. All right, in that case, we would like to thank you all for your time. Some of you know my email address, and some of you might know Elijah's email address. And if you have any questions or need more information, you're welcome to send us emails. We'll be glad to help you in any way we can. Once again, thank you for taking time from your busy schedule to attend this presentation.
Thank you.